So coming to the deep learning approach, like I'll explain you two projects. One is for two classes prediction. If you have only two categories, how we can approach, and if you have more than two categories, how you want to approach. I'll explain you both the things. Okay. So now initially, so I'll check the runtime. Could be change manage sessions, change runtime type. Yeah, it's done. It's good. Now initially, like we have to upload the data set, as you know this step. So I'm terminating that session. So previous runtimes will be disconnected. So this is a project which is used to predict brain tumor. Remember guys, whenever you want to take help of any binary classification problem, same code you can use it. Okay, same code template you can use it. But the thing is, you should be careful that like how many subfolders you're having, how to take up that subfolders. You should be very clear with that part. And we are installing Kaggle as it is already there. It is not required. And this setting up path also not at all required. I told you, like without that also it will be come up. Now we are downloading the dataset, and it is a dataset URL. You can check it from Kaggle. So I'm going in a direct way, but coming to you now, you should start with this dataset one. Initially, you can go to Kaggle. You can choose the dataset first. Then you can take that. It is having 88 MB, 88 MB data. And from this, you have to do copy API command in the code. And here you have to paste it. In front of that, you have to add exclamation mark. So after that, we'll get a data in the form of zip file. We have to unzip the data. So for that, this is a command unzip. And here we are creating one folder. Make directory means we are creating one folder with the name dataset. So by unzipping the data, I have to move all the data into dataset subfolder. That's why I'm creating one folder. Okay. So now I'm unzipping this folder first and I'm making one folder. Okay. With the name dataset. Now in the dataset, like here you can see very basic commands I'm using. Move. So if you look at this thing now, after unzipping this data, you can see a lot of subfolders are come. So he will be having data set here. In this data set, it is now not having anything. But in this data set, you can see we'll be having no. In the no category, we'll be having images related to there is no brain tumor. Similarly, in the S category, we'll be having images corresponding to the people, those who are having brain tumor in their images. Now what I am doing is, so this S subfolder, I have to move it to dataset folder. Similarly, no subfolder, I have to move it to dataset folder. That's what I'm doing here. So that now the images will be structured. So dataset we created, right? In this, we added two folders. One is with the name S, another one is the name no. Okay. Now you can see all the images corresponding to S and no in this. Just we moved the local folders into this dataset folder. Like this, you can move any subfolder into other folder. So now we are importing essential libraries. As you know, all these essential libraries. Additionally, we imported computer vision package. The purpose of computer vision package is image processing. Apart from that module, as you know, remaining all the packages. The next, we have to iterate through each and every image. So first step, whenever you want to work upon any CNN project is, all the images should be in a standard size. So for that purpose, we have to iterate through dataset folder. In this folder, we'll be having subfolders like S and no. We have to iterate through those folders. So for that purpose, I'm saying image path is dataset slash. Means I have to go through subfolders of dataset. And I have to convert each and every image in the form of 224 plus 224. That's why I'm specifying image size value to 224. Now I am checking in the image path what are the subfolders are there by taking help of OS module. As it is not a mandatory step, you can skip it. But if you want to cross check whether some subfolders are available or not, you can run this command. The next, you can see this is a very important code block. Whenever you want to approach any deep learning project, it's a heart for any CNN based project. So in this, like what we are doing is we are pre-processing the image. It means we are going through this datasets folder and we are taking each and every image and we are standardizing that image first. So if you look at this, in the get data function, we are taking one function. We are like it is a attribute variable. We can pass the data later. Now, what I am going to do is all the images that I have to store it in one list, and all the images labels, yes or no categories will be having, right? Those things I have to store it in labels list. So for that purpose, what I am doing is I am iterating through this class names. So in this example, class name means image path, means this list. Class names means this list. It means we are iterating through this list. So initially it will take class name means S. It will take class name like S. After going into this, in the labels list, we are adding the S. We are adding name S first. After adding that, we are taking one more for loop. In this S folder, further we have to go through each and every image. So previously we saw like how it will give. Okay, now os.list path means it will give all the image numbers. It means now we are going through each and every image. We are going to each and every image. While going to each and every image, we are taking image array. The images will be measured in the form of NumPy arrays. We are reading each and every image by taking help of computer vision package. cv2.amread, we are reading the images. os.path.join of path comma image. We are reading the images like this. Then next, we are reading all the images in the form of colored images. Then next, in the computer vision package itself, we can see we'll be having resize function. Previously, we defined image array equals to 224. Now I'm saying 224 comma 224 comma 224. It means I am resizing each and every image in the size of 224 cross 224. Now I am adding this resized image into image data. So here the image data will contain 224 plus 224 now. Now class number. Labels that append, coming to the labels, I am attending, like I am keeping that class number. Okay, class number means that index. So S means it will be add like 0. No means it will add like 1. Okay, if there is any errors, I want to see that error. Finally, I have to return the array of images and the labels, 0 or 1. I have to get it. Now I have to apply that function on our data. So for any deep learning project, the structure will be very same. Pre-processing steps will be very same. You need not to change this code at any time. So now you can see whatever the data set we took, totally will be having 3000 images. Image array means all the images present in the image list. Okay. The next 224 cross 224, it means image pixel values. 3 means it's a colored image. So if we have channel value means it will be a colored image. 3 means like any colored images will be formed with RGB colors, right? That is corresponding to value 3. Coming to the output, will be having 3000. If the category is S, it will store like 0. If category is no means, it will store like 1. So that is the meaning of that. Now, we'll see. I think it will give an error. Class names here will add some X. Otherwise, it will give an error. Yes, we are plotting the graph for each and every category, like how many samples available for each and every category. So missing one positional argument, like stick labels. At which line we got an error? Okay, we got an error, right? Like I'm taking help of AI. It will explain an error. I'm asking Gemini to resolve this error. So now it will give us a refined code. We can use the same code now. Yeah, I'm going to use same code. We'll see how it has given a plot. So now it won't give a plot as of now. We'll see. Okay, okay, it has given finally. Does it give any output? It's not giving anything, right? So here we have to add a name. We'll go to code. Actually, here we have to add, like this count plot is got updated in the recent days. Now I'm saying x equals to labels. I'm adding this. Yes, you can see. So I said x equals to s. Now you can see the categories. So both the categories images having an equal proportion means we should not think about, like, we can consider accuracy as a performance metric. And it is a code block which is used to read the random images from the data set and to display them. So how many times you run this code block, that many times random images you can see in an output. You can see. So in the what I am doing is I'm plotting a subplot in the size, each and every image in the size of 15 cross 15, and we are iterating through all the images. And sorry, we are taking 5 rows and we are taking 2 columns, and randomly we are reading the images from the data set. Random.randint means it will take random images from 0th index to last image, and we are displaying all the images. So you can see what is the category of image. You can see the name, like output class is name on the top, and you can see the image at the bottom. How many times you'll run this code, you'll see the images that many times. So finally, the image pixel values will be in the range of 0 to 255. Here also we have to standardize each and every pixel. So to standardize each and every pixel, we'll take help of preprocess input function. And we can apply this preprocess input function on the complete image data, so that each and every image will be preprocessed, and it will, like, each and every image pixel value will be converted in the range of -1 to +1. Okay, and here what I'm doing is image data of 0 means I am looking the data of first image, whether it got changed or not. I want to know that. That's why I applied that. So now you can see the each and every pixel value will be changed in the range of -1 to +1. Similarly, now we'll be having output, right? So coming to the output, we'll be having 2 categories, yes or no. So finally, to judge that thing as well, here we are taking help of 2 categorical function. So by taking help of 2 categorical function, so previously, like, 2 categorical means it will work like in one hot encoder. In a scikit-learn, how one hot encoder worked, here 2 categorical also works exactly same as that. Now labels of 0. So coming to the output, previously we'll be having yes or no, right? Now we change it to numerical values. The next step is we have to split the data in the form of input and output. We are doing that. Image data is nothing but our input, and labels are nothing but our output. We are specifying test size as 20 as is. We are splitting the data into training and test set. Now, out of 3000 images, 2400 images are considered for training. Remaining 600 images we are considering for testing the model performance. Then next, we are taking help of Inception V3 model. In this example, we are taking Inception V3 pre-trained model. So coming to the convolutional neural networks, whatever you see in a basic project, coming to the basic project, we created all the layers and we applied the data, and finally we observed the output. Whereas coming to the pre-trained models, these are predefined architectures, CNN architectures. We are taking help of pre-trained architecture. So here we are taking Inception V3 model, and we are taking it from TensorFlow only. Pre-trained models means machine learning will be having different algorithms, right? Like that, here pre-trained models also like algorithms only. Okay, now layers we are importing, model we are importing everything. And coming to the Inception V3 model, whatever we are importing, we are specifying the parameters for that. Weights. Weights I have to consider from ImageNet challenge. Okay. And input shape like 224 class, 224 class 3. Okay. The next, for this model, we are adding additional layers. You can see for layer in inception dot layers colon -1. It means we are iterating through the Inception V3 model. We are taking all the layers except output layer. In front of output layer, we are adding further layers. That's what we are doing here. So to add any layers, we should have a sequential first. Okay, I told you previously to flow the data between input to output, we should have this one. Coming to the sequential model, we are adding additional layers. So coming to the sequential means it will start with input. For this input, I am adding complete inception. Inception means all the layers except this output layer. So we are adding this inception. Means for our input, we are applying inception V3 model. After adding inception V3 model, in front of output layer, we are adding flattening layer. And then next, we are adding fully connected layer at the last. After flattening layer, we are adding one more layer. Okay. So now we are adding this layer as an output layer. So coming to the output layer, the output should be based on number of classes. So previously coming to the activation function, we used sigmoid activation function. If you remember ANN project, there we use it sigmoid activation function. Here we are using softmax activation function. If you want to give two different outcomes, we can take softmax. Whereas if you want to give output based on probability, you can use sigmoid here. Okay, the meaning of this thing will be like to make you understand, I'll take help of, yeah. So let's suppose if we take sigmoid activation function, you'll get an output with a single node. So based on probability, you can say, if it is above 0.5, we can say category like S. If it is above 5 means category S, 0.5 means category S. That is about that sigmoid activation function. Whereas whenever you use softmax activation function, how many output categories are there? That many nodes will be come up. So this node corresponding to S category and this one corresponding to no category. Okay, for each and everything, you'll get a different probability values. So let's suppose here if you get 0.3 and here you'll get 0.7. Who is the whatever the value is bigger value, we can say that as a final category. Okay, that's about softmax activation function. As you know, after building the model, we have to compile the model. In this step, we are compiling the model, however we did previously. And the next, here we are looking at the summary of the model. Summary means like how we constructed the model. We are looking at the model structure. You can see the model structure, whatever the model we constructed, how it looks like. Okay. The next, we have to train the model. To train the model, to avoid overfitting problem, we are taking help of early stopping. The model learns more and more parameters. If it won't comes to the global minima, at the time I am saying the model to stop it. Like that, we specified additional parameters to the model. After specifying the additional parameters, we are training the model. Training means fit method. In the fit method, we have to specify X train and Y train. And to check the model performance, we can specify validation data as well. Based on which test data, we have to give test accuracy. That is also I'm specifying here. Epochs means number of iterations. Batch size means for each and every iteration, how many images it should consider. Callbacks means callback list we define on a top. We are going to this. Okay, now this model will start running. So we said 3 epochs, right? It should go through all the images 3 times and it will adjust the weights and finally it will give some accuracy. One epoch is done. In the first epoch, we got 93% accuracy. And it got improved further 93.8% accuracy. And finally, we got an accuracy like 97 percentage. Okay, then next, what I am doing is after training the model, I'll plot the accuracies graph, training accuracy and validation accuracies graph. So training accuracy means while training the model, how it is behaving, like how its accuracy will be. And the validation accuracy means on test data, our model performance will be how it is. Okay, we are looking at that. The next, we are checking like we'll plot a confusion matrix for this based on a test data. As you know how we did previously, like the steps are different, but the graphs will be same. So confusion matrix, the same thing, whatever we plotted previously. We are plotting confusion matrix for this problem. As you know confusion matrix, by looking at this graph, you'll understand how it would be. Okay. The next, whatever the model we built, we are downloading that model. Inception V3 model architecture, how it would be, how we added layer. So previously we'll be having Inception V3 layer. So on top of input layer, we are adding Inception V3. Coming to the Inception V3 model, we are adding additional layer, like a flattening layer and dense layer we added. That thing we can see in this image, as you can download this image after constructing a model. Okay, so finally, if you want to test it for some test image, so let's suppose I have to check how my model is behaving for some test image. For that purpose, we'll be having predict folder here. Now I'll download some images from this. Download. And I'm downloading few more images. Download. Okay. As I downloaded two images here, now I'll add one more code line here. Loaded successfully. Like this, I'm writing some comment. Now I have to upload the image. So now here, like we downloaded the images, right? Spread up 0, I'm adding now. Okay, open. So 100% this image got uploaded. Now, whatever the image name you got here, exactly the same name you have to specify here. Spread up 0. Okay, I'm keeping same name. So now we are pre-processing that input image. After pre-processing, it will how it look like. We are looking at this. After that, we are performing prediction and we are plotting that thing in a graph. So now we got an output finally. So you can see whatever the image we updated here, uploaded here, that is belong to category no. Okay, it means based on this MRI image, we can say that person is not having like a brain tumor. Similarly, like if you want to take the image directly from this path, what you can do is you can copy path. I'm doing copy path and I'm keeping that path here. I'll copy the path. Directly, I'll execute this. Now this image got read here. This is the image. Now if you run this portion now, you'll get some output. So whatever the image you uploaded here also, it is also the image which is belongs to no brain tumor. Like this, you can test it for any image. And this till this, it is a project. And at the bottom, whatever it is there, I did additional analysis for image processing only. Okay. So this is about the project. Perfect. Thank you.